Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Nur Sharifah binti Razali and we are from group 4 that conduct a question 3. So for the introduction, basic on this map, operational research about this topic is at the center, which Bradshaw highlight is focused on problem solving through the use of math and method. The two main branches represent optimization, also aiming for the best solution and analysis. Further details include how it improves efficiency aids in resource allocation and the support decision making in areas like logistics, supply chain and project planning.
Hi, my name is Naranati Sabah and I will explain for the question 1. So, Millennium Herbal Company shipped truckload of grain from 3 silos of 4 miles to supply and the demand together with the unit transportation cost per truckload on the different routes are summarized in the transportation model in table below. Find an initial basic feasible solution by the northwest corner method and then find an optimal solution. As you can see, for the ABC is ship truckload grain and for the DEFG is a destination that they need to go. For the requirement, considered as demand, and for the available, considered as supply demand. To solve this question, we need to use the northwest corner method. In the northwest corner method, the largest possible allocation is made to the cell in the upper left-hand corner of the table, followed by allocation to adjacent feasible cell. As you can see, for the factory D, which means in column D, row A, demand for 200 items and store A have 250. So, remaining item for store A is 250 minus 200 equal to 50. Okay, so for the factory D is to fulfill their demand. And factory E get only 50 items from store A, have remaining 225 minus 250 equal to 175 to be fulfilled. Next, factory E get the remaining item from store B, which is 300 minus 175 equal to 125. We move to store B. They provide 175 items to factory E. Factory F, which is 275 minus 125 equal to 150. Next is store C, which is 400 minus 150 equal to 250. So to calculate the total cost is 200 times 11 plus 50 times 13 plus 175 times 18 plus 125 times 14 plus 150 times 13 plus 250 times 10 equal to 12,200.
Okay, my name is Muhammad Shafi Naim bin Wasri. Now I would like to explain about this part. Okay, since we need to find the optimal solution, we need to use Modi method. So the first step, we need to know the formula for occupied cell in Modi method, which is UI plus VJ equal to CIJ. Next, we need to set UA equal to 0. Okay, then we proceed to find the value for CAD. The first equation will be UA plus VD equal to 11 since the unit transportation cost is 11. We will repeat this step until we get all the values for U and V. After finding the values for U and V, we need to find the value for empty cells using the formula empty cell equal to Cij minus Ui minus Vj. For the first empty cell, which is XAF, the formula is XAF equal to 17. The unit transportation cost for the cell minus UA, which is 0, and minus VF, which is 9. So we get the value of XAF equal to 8. We repeat the same step for all the empty cell and we get the values for all the empty cell as shown below. As you can see, all the values for the empty cell is positive except for XBG. So we need to optimize the value for cell XBG. So by using Modi method, we need to add 125 from cell BF to cell BG and CF and minus 125 from cell CG. So the new value for cell BF is 0, BG is 125, CF is 275 and CG is 125. To find the optimal cost, we still use the same process which multiply the demand value from each cell with the unit transportation cost and add it up together. So finally, we will get the optimal cost is 12,075.
Hello, my name is Lukman Hakim Berzukonai, and now let's move to the solution for questions 2, which is to find a critical path for each activity network. So the first thing we need to do is to find a critical path of each activity network. For the first one is ADHM, which is 19, AIM, which is 17, BEJM is 20, CFKN is 16, and CGLN is 20, which is that has been shown that we have two critical paths, which is 20. Okay, let's move for the step 1, which is forward pass. So let's look at all of the letters and numbers. For the letters A is 6, and before 6 is 0, so 6 plus 0 is 6. And then move forward to D, 6 plus 4 is 10, and H is 10 plus 3 is 13. But we cannot move to the M because there is two more paths that will going to join M. So let's move to the next one. For the A is 0 plus 6 is 6, and move to the I, 6 plus 5 is 11. And move to the B, 3 plus 0 is 3, 3 plus 7 is 10, 10 plus 4 is 14. So let's move to the M. Before for M is we need to choose the highest number, which is 14 from J. So 14 plus 6 is 20. So that go to the finish one is 20. We go to the C, 0 plus 4 is 4, 4 plus 4 is 8 at F. At K, 8 plus 3 is 11. And go to the C plus, again go to back to C, 4 plus 0 is 4. Go to G, 4 plus 6 is 10. Go to L, 10 plus 50, 10 plus 5 is 15. And go to N, we choose the highest one is L, which is 15. So at N, 5 plus 15, which is 20. And we can see we have two critical paths that has a highest number, which is 20.
Hello and Assalamualaikum to my respected lecturer, Madam Rafidah binti Ali. My name is Nur Aditah binti Ahmad Rashdan. So, as you can see that the project's completion time is 20 weeks. Now, let's do the backward pass since the project completion time is 20 weeks. So, the latest finish times for activity at the finish node M and N must be 20. That is, M and N cannot be completed in the longer than 30 weeks. Next, we obtain the latest start time by subtracting the activity times from the latest finish times. For N, the latest start time will be 20 minus 5 will be 50. For activity M, the latest start time will be 20 minus 6, and that gives 40. Now, from activity Hij is the same successor, which is activity M. So, H is the latest start times will be 40 minus 3 and will be given the latest start such as 11. For activity I, we can see that the latest start time is 40 minus 5 and will give latest start which is 9. Another part from activity J The latest start time also 40 minus 4 and given 10. So let's take a look at activity K. The latest start time is 50 minus 3 and get the answer 3. For activity L, the latest start time is taken from activity X, such as 50 minus 5 give 10. Okay, now G only have one successor, which is from the activity L. So the latest finish time for G will be the latest start time for L, which is 10. And the latest start time will be 10 minus 6, which gives 4 for latest start time activity G. Next, activity F also have one successor, which is from the K. The latest start time will be 12 minus 4, give the 8. So, likewise, activity E also has one successor, which from the activity J. The latest start time will be 10 minus 7, which have 3. Anyway, the activity G also have one successor, such as H. So we can see that at the latest start time, we will get the 11 minus 4, which have 7. Now, C has two successors, F and G. Their latest start time are 8 and 4 respectively. As a result, the latest time C must finish to be 4 for G to start. Now, C has two successors, F and G. Their latest start time are 8 and 4 respectively. As a result, the latest time C must finish to be 4 for G to start. In essence, when doing the backward pass, the latest finish time of an activity must be the minimum of the latest start time of its successors. Thus, the latest start time for C will be 4 minus 0 to give 0. Now, we can see that the activity B has one successor E with the latest start time is 3 and its latest start time will be 0. Now, activity A has two successors, which is for B and I, but the minimum number is activity G, which is 7. So 7 minus 6 gives 1. The backward pass is now completed. Moving forward for the next slide, which is slack number. Now, slack for an activity is defined as how long the activity can be delayed without extending or increasing the project completion time, and it is calculated as LS minus ES or LF minus EF. So, the slack for A will be 1 minus 0 or 7 minus 6, and we can get the slack number is 1. The activity B, we can get the slack 0 because 0 minus 0 or 3 minus 3. Activity C, we can see get the slack is 0. Now activity D, also we can get the slack number is 1. For E, we can get the slack number is 0. For F, we can get the slack number is 4. For G, we can get the slack number is 0. Next, H, we can get the slack number is 1. Activity I, we can get the slack number is 3. Activity J, we can get the slack number is 0. Activity K, we can get the slack number is 4. Activity L, we can get the slack number is 0. Activity F, we can get the number is 0. And lastly, activity N, we can get the slack number is 0. Therefore, we have two critical paths, such as activity B, E, J, and N. And also, the other part of critical path, C, G, L, and these two critical paths cannot be delayed at all without extending the project completion time. The activities with 0 slack are all critical activities, and they are from a critical path, which is the longest path in the network.
Hi, my name is Nur Sharifah binti Razali. So, I will answer the solution question number 3. On the question, two go downs, A and B have green capacity of 100 quintas and 50 quintas respectively. They supply to 3 ration shops, which is D, E, and F, whose requirement are 60, 50, and 40 quintals respectively. the cost of transportation per quintal from the go down to the shop are given in the following table. So, based on the table, how should the supply be transported in order that the transportation cost is minimum? What is the minimum cost? So, for the Norwest method, as you guys know, in the Norwest corner method, the largest possible allocation is made to the cell in the upper left. Firstly, let's see to the A. The demand is 100 but they only can supply 60. So, the answer is 60, and the next E, the only left to the enough the demand 100 is 40. So, let's see the F, 2.5. The demand is enough, so let's proceed to X. Next, B. The demand is 50, but they cannot supply anymore, so let's proceed to X. Next, the demand is 50, but they only can supply left is 10. And the last one is the demand is 50, but to enough the 50, they only can supply 40. So the answer is 40. Let's see the answer. 6 multiplied by 60 plus 3 multiplied by 40 plus 2 multiplied by 10 plus 3 multiplied by 40. The answer is 620 ringgit Malaysia. For the minimum cell method, is cost will provide a solution which a lower cost than a Norwest corner solution because it consider in the allocation process. The first thing first, let's see to the lowest cost. The lower cost is 2, and then the demand is 50. So they only can supply 50. So we need to process to 50, and automatically the demand of the B for the numbers 4 and 3 is X, and also for the 3, the demand is also X. So let's go to the 2.5. The 2.5, the demand is 100 but they only can supply 40, so we need to proceed 40. And the last one is 6. The demand is 100 but they just only can supply 60. Now let's see the answer. 6 multiplied by 60 plus 2 multiplied by 50 plus 2.5 multiplied by 40. The answer is RM, 560 ringgit Malaysia. Next, I will pass to the Alia Izazi for continue the question. That's all from me. Thank you.
Alright, I'll continue with the Vogel's approximation method. For this method, the first thing we need to do is to determine the penalty cost for each row and column. A penalty cost is the difference between two lower cell costs in a row or column. For this question, the penalty cost for the first row is 6 minus 4 equal to 2. Second row is 3 minus 2 equal to 1. And for the third row is 3 minus 2.5 equal to 0.5. As for the first column, 3 minus 2.5 equal to 0.5. And for the second column, 3 minus 2 equal to 1. For the second step, we need to select the row or column with the highest penalty cost. The highest penalty cost for row is 2, while the column is 1. Next, we will allocate as much as possible to the feasible cell with the lowest transportation cost in the row or column with the highest penalty cost. We start with the one with the highest row penalty cost, which is 2. fill the cell that has 4, which is the lowest transportation cost, with 50, which is demanded. Then the balance then will be given to the next cell from the same row. The rest of the supply, that is 50 and 40, will also be given to the column A to meet the demand of 100, as the demand for column B has been met. Then we calculate the cost 6 times 10 plus 3 times 50 plus 2.5 times 40 plus 4 times 50 equal to Rm 510. Finally, we will get the result of the 3 initial feasible solution. For the northwest method, the result is 620 ringgit. For minimum cell cost, the result is 560 ringgit. And for the Vogel's approximation method, the result is 510 ringgit. Therefore, the best minimum cost is 510 ringgit, which is the Vogel's approximation method.
Last but not least, for the conclusion of this topic, based on this map, the conclusion is broken into down several components. It begins with a summary of finding, highlighting, and main outcome. Decision support is a central theme, branching into recommendation for action and acknowledgement of limitation. Future decision suggest area for further exploration, and implication consider the border impact. Finally, communication of result address how the finding will be shared and implemented. This visual representation provide a concise overview of the key aspect involved in concluding an operational research study. So, that's all from our group. Thank you.